From man's earliest days, the problem of moving and controlling liquids has been an issue of great importance, even of survival. By 500 BC, the water wheel was a common sight throughout the known world. Around 230 BC, Archimedes invented the water screw, which is still in use today. In 50 AD, Hero of Alexandria invented Hero's steam machine, a primitive steam turbine. Then, in the 1700s, through the work of Thomas Newcomen and James Watt, the steam pumping engine, and thus the modern pump industry, was born. Over the last 250 years, pumping technology has evolved to the highest levels of integrated engineering sciences.
If we go back and look again at the heritage companies, which are made up of a good many, the dominant technological skill in all of those companies has been hydraulics.
We have a baseline of experience from which we can move ahead. So from that perspective, we're well positioned to move into almost any area of technology.
One of the great things about this company, especially when it comes to technology, is that we have several centers of excellence, which are virtual centers of excellence in various fields. Fluid dynamics is one. We also have mechanical analysis, mechanical design, materials, mechatronics. When anything happens in the field or a customer likes an advice or is asking for something, we are gladly to give it, and we tend to step beyond boundaries.
The organization these men are talking about is Flowserve, one of the world's largest pump companies. Tracing its heritage back to 1790 London, Flowserve is the undisputed leader in pumping technology, with an exhaustive list of industry firsts to its credit. Most of the engineered pumping machines operating in the world today were derived from original design concepts developed by entrepreneurial engineers from Flowserve heritage companies. Today, Flowserve continues to possess a passionate commitment to technology and innovation. In fact, it is one of the company's core strategies. Through its Applied Technology Group, this research and development expertise in fluid dynamics, mechanical design, engineering analysis, mechatronics and material science is now available to those pursuing creative, innovative solutions to pumping problems.
If we look at high energy machines, higher speed gives you physically smaller machines. That poses its difficulty though, because you have to get the fluid dynamics correct, and you really have to get them very correct in order to run machines at very high speeds.
The main field of interest nowadays is cavitation. It always has been in pump applications and still is. And CFD is a great tool nowadays to study that in more detail. When doing a cavitation study or an analysis, we try to determine the shape of the cavity that will form. And from that cavity shape or cavity length, we will determine the amount of erosion rate that will come from it. So we know that after 1 year, 2 years, 3 years or 10 years time, we have a certain amount of cavitation damage or cavitation pitting. And that's exactly what the customer is interested in.
It often occurs that customers still require us to do flow visualization tests on high energy applications. Often what the customer wants to see is a limited amount of sheet cavitation to be sure that the lifetime of the pump is guaranteed.
We can visualize when an incipient cavitation is happening, when the first bubble is formed, and then take actions to avoid that in the field.
We have now coupled the CFD tool with an optimization tool so that together it becomes a design tool. With this design tool, we use parameterized models for the pump impeller that we put into a CFD tool.
We start by calculating the flow within a passage. We construct an objective function with the objectives we want to include, and then we try with cutting-edge numerical techniques like a genetic algorithm to minimize this function, so to get the best geometry out of the design space.
The adoption of genetic algorithms in the design process is very important because it enables us to deliver impeller designs that are unconventional and that no one has ever tried before.
Customers want to be able to operate their pumps outside of the design envelope. It's whatever the demands of the plant require, and they will operate these pumps in ways that were never envisioned.
The computational tools that we have available today in the company are for sure the necessary instrument to reach more severe limit for application on the high demanding pumps.
With 3D modeling and CFD, finite element modeling and so on, we can actually look at these design conditions in detail. We can actually model them and predict what types of vibration perhaps or stresses or instabilities in the flow that may be happening.
We are looking forward to a better fluid dynamic design in order to reduce by 30% and more the weight of the pump and extend the mean time between failure to achieve a longer expected life of the pump.
The real advantage of 3D modeling is that you can check your assemblies. You can take any 3D model and put all of the loads on it, get stresses, deflection, vibration information, natural frequencies, determine if you're going to have certain field problems in advance, and then you can make modifications to that model and see how you've improved it.
All the vertical pumps that we design in our facility, we conduct a reed frequency analysis using rotor dynamics and finite element analysis, which confirms that no problem of that nature is going to happen on a site. That is one of the best things we can do for our customers.
Mechatronics is really kind of defined as a synergistic integration of a number of different technologies, and these include things like electrical, electronic engineering, mechanical engineering, sensor technologies, computer technologies, and actuation technologies.
We as pump manufacturers know how the pump works really, really well. So people have tremendous experience in the industry to diagnose pump problems. With mechatronic systems, what we are trying to do is capture their diagnosis ability or capability to detect problems.
We want to actually be able to embed the intelligence directly on our equipment such that the pump itself would monitor its own condition such that you will not have to go out and collect raw vibration data, for instance, from that piece of equipment. The piece of equipment can gather its own data, run its own diagnostic and prognostic algorithms, and give you information about the status of that piece of equipment.
So, end of the day, you come back to saying, what do I need to do all these things? I need to be able to monitor, gather, and collect data, which goes to the heart of the mechatronic system, which is instrumentation, and the ability to collect data and interpret data to the customer's benefit.
Flowserve is a company that combines a number of different heritage pump companies that has brought to the table various approaches to engineering problems, to the use of materials and coatings. We're focusing today particularly on several different types of coatings and surface treatments, including weld overlays. Specifically, we're looking at various types of coatings that can be applied using a laser, including a tungsten carbide, which we believe offers considerable opportunities for the future.
There's a variety of surface treatments. Plasma coatings is probably some of the newest ones, where people are generating plasma gases so we can coat internal passages. In the coating area, there's a lot of developments going on, and in the HVOF, or high velocity oxy-fuel type process, suppliers now are making nano-sized powders, which gives us much better coating, a denser coating, less porosity, and that provides more benefit for wear resistance and corrosion resistance.
A particular success that we've had in recent years has been a material that we developed known as X-Cavalloy. This is a unique stainless steel developed specifically for cavitation resistance. It's an austenitic type chrome manganese stainless steel that has cavitation resistance far better than all conventional materials that are used for pump components. We're currently looking at materials and processes from various sources that are not currently being used, but we think with the right modification or improvement would represent something that would allow us to offer a better product suited for very severe applications 5 or 10 years from now.
These technology tools will help us step by step to be one step ahead of our competition.
You're trying to improve the reliability of the total pump package, seals and pumps, and you're also trying to improve the efficiency of the pump. So that gives a cost reduction for the customer.
We have a large group of engineers and advanced level engineers in our technology team that I think are some of the best people in the world. They're recognized by many of the industries. They participate on committees. They participate in councils. We drive many of the standards that you see as industrial standards. So our people are the kind that not only work for Flowserve, but they actually support the industry.
There's no engineer here that has to go it alone. He can call up an expert and get advice any day of the week. It's great. It's great to be surrounded by experts from all over the world.
The interactions with the people from different culture, different educational background, a different interest is very stimulating and will permit to synthesize the best approach for the best objective.
Customers see us as a solutions provider. They need someone that can resolve the problems that they have, and sometimes someone that can offer solutions to issues that they don't even know they have. The only way to do that is being a leader in technology.